Let's talk about how to use the p-value in a test of significance to make a decision about whether there is evidence or insufficient evidence to support the alternative hypothesis. As a reminder, the p-value, which is a probability value, it's measuring how likely you are to have gathered a particular sample, a sample with your sample statistics, so your mean or proportion, if the null hypothesis really is true. Remember, we sort of are setting up or seeking to discredit the null hypothesis by assuming the null hypothesis is true and then seeking evidence that would be a contradiction, that would be a weird situation. And this is done by looking at the p-value, looking at how likely it is to have gathered our sample, assuming the null hypothesis is true. So, to make a final decision about whether or not there's evidence or insufficient evidence to support the alternative hypothesis, what you do is compare the computed p-value to the given level of significance, whose symbol is alpha. So you compute p-value using GeoGebra. You get your level of significance generally by being told in the problem. In real life, you also choose what level of significance you want to use based on what the situation is, but here you will be told alpha. So you make your decision by comparing the p-value to the level of significance. Specifically, if your p-value, if your probability that your sample would happen randomly if the null hypothesis is true, if that p-value is less than the level of significance, that is evidence to support the alternative hypothesis. And if your p-value is greater than the level of significance, that is insufficient evidence to support the alternative hypothesis. Remember, since the p-value is saying how likely it is that we would have ended up with the sample randomly if the null hypothesis was true, this means a small p-value, a small probability. We say, whoa, this was unlikely to have happened randomly. It seems likely the null hypothesis is not true, meaning there's evidence to support the other option, the alternative hypothesis. Small p-value is evidence to support the alternative hypothesis. A large p-value, so a p-value that's larger than the level of significance, you'd say, this could have happened randomly, this sample could be chance, this is not necessarily evidence for the null hypothesis, but it's insufficient evidence to make a claim that something else is happening. So again, small p-value, something is up, evidence to support the alternative hypothesis. Large p-value, we don't know, this could be chance, insufficient evidence to support the alternative hypothesis. The argument is always about supporting or not supporting the alternative. We never make a claim about the null hypothesis, it's just the two options are evidence, insufficient evidence to support the alternative hypothesis. So, for example, let's suppose we had a problem, we find the null and alternative hypotheses, we get our p-value using technology. Our p-value in this case is 0.0325. Let's consider two different levels of significance and see what decision we would make in both of those cases. So let's say the first case, let's suppose we found a p-value this, and we want to use a level of significance of 0.05 to make a decision whether we have evidence or insufficient evidence to support the alternative hypothesis. So we say, what we want to do is just compare the p-value to the level of significance. So in this case, I'm going to compare the p-value 0.0325, and I'm comparing it to the level of significance. And in particular, we can see that 0.0325 is less than 0.05. Quick tip, in order to compare fractions like this or decimals like this, sometimes it can be a little annoying or it can be a little tricky. A hint is what you can do is add zeros after the last non-zero digit until both of the expressions have the same number of digits in them total. So if I was having trouble seeing the relationship between those two, what I could do is I would write out my p-value again, and then I'm going to write my level of significance, but this time I'm going to keep adding zeros until so this guy has 4 digits. I'm going to keep adding zeros until this expression also has 4 digits. So I'm going to add 2 more zeros. And so we can think of this ultimately as comparing 500 to 325. Since 500 is larger than 325, 500 is greater than 325, we can say for sure that 0.0325 is less than 0.005. 0.005 is greater than 0.0325. So I have compared my p-value to my level of significance. In this case, the p-value is less than the level of significance. So therefore, we say, since the p-value is less than the level of significance, this is evidence to support the alternative hypothesis. Moving to the next example, if alpha is equal to 1%, the first thing I need to do is convert this into a decimal or convert my p-value into a percentage. I just need to use them the same. So I'm going to remember that 1% is the same as 0.01. And then I say, all right, I'm going to compare my p-value to 0.01. So 0.0325, comparing that to 0.01. The question is, which one is larger? Again, I could use this trick if I want to keep adding zeros until they both have the same number of digits. This one has 4 digits, so I would add 2 more extra zeros to there and say that, yeah, 100 is less than 325, so that means that 0.0325 is less than 0.01. Sorry, I said that wrong. 0.0325 is greater than 0.01, the thing that I wrote. 325 is larger than 100. And so this means in this case that my p-value is greater than the level of significance. P is greater than alpha. This would be, therefore, insufficient evidence to support the alternative hypothesis. We're in the second case. Again, it's saying that the likelihood that my sample would have occurred by chance is about 3.25%, and if we chose a level of significance of 0.01, we're saying I need the likelihood of my sample to have occurred randomly to be less than 1, there'd be a less than 1% chance of that. And since 3.25% is larger than 1%, we'd say this isn't likely enough. This is likely enough that this could just be chance, that my null hypothesis could still be true. We have insufficient evidence to support the alternative hypothesis. Let's do one more example. Let's suppose now, different study. We found a p-value of 0.0152. We want to make a decision using a significance level of 5%. So the first thing I'm going to do is convert my significance level to a decimal, just so I can visualize it. 5% is 0.05. And then I'm just going to compare p to alpha, decide which one is bigger. My probability is 0.0512. Again, alpha is 0.05, so deciding which one is larger, they're very close, but p is larger. Again, if you're having trouble visualizing it, add more terms. You don't have to, but 512 is larger than 500, so 0.0512 is larger than 0.05. And so therefore, because the p-value is large, that means this could have happened by chance. This means there is insufficient evidence to support the alternative hypothesis. And there we go. That's how you make these decisions. Hope this helps.